The AI scientist generates and researches its own ideas, documenting the results in actual scientific papers, with charts and everything. The AI Scientist was published on September 12th of 2024 by Sakana AI of Tokyo, Japan. The first peer-reviewed publication was on March 12th of 2025, entitled Compositional Regularization: Unexpected Obstacles in Enhancing Neural Network Generalization. It explored how to generalize a neural network to reason beyond problems seen in training data. It tried compositional regularization and concluded it did not help. That was the entire point of the paper. To date, the AI scientist has published at least 269 peer-reviewed papers. All of the AI scientist's published papers are in a topic related to AI research. This is likely because it is prompted to believe that it is an AI researcher. To do its work, the AI scientist depends on a large language model, which is called LLM for short. This is a type of machine learning model that, given a record of what has already been said, excels in figuring out the next word. With this ability, one word at a time, it can generate just about any kind of text. Here's an overview of how the system works. Launch Scientist is the root process, which calls all the others. Generate ideas comes up with ideas to research. Check idea novelty to see which is a new idea or not. Do idea is the root of actually running the experiments and producing the report. Perform experiments goes through all the experiments that were planned and runs them one at a time. Perform write-up generates the report, just an initial version. Perform review creates a critical review. Perform improvement uses that review to generate better versions of the report. To see how it accomplishes this, let's take a look at its source code. This is where it all begins, with the call to Python to launch scientist.py. As you can see, there are three parameters. Model, which indicates which pre-trained model to use. Experiment, which says where to find the templates and where to save the output. And also numideas, which indicates the maximum number of ideas to generate and test. This is the main process that coordinates all activities, calling the other procedures to run their steps. We will branch off to discuss sub-procedures from here. First, it parses the arguments, including model and the others described before. Next, in this area, it figures out which GPUs to use. These lines just say if the user requested that it write in LaTeX and it's not available, then stop, because that's the only form of output that this can produce. Now here it creates an instance of the model requested. In our case, it was GPT-4o 2024, but it can do any model required. Here we get the template folder for reading the files required to run the experiment. Here we get the results folder where we'll save our output. Next is actually generating the ideas. Next, we go to check idea novelty. This function is to determine whether the ideas are new or derivative by referring to previous research. And by the way, we'll come back to generate ideas and check idea novelty to see those in detail. Let's just mark them for later review. Next here, we take those ideas that were generated and write them into a file for later reference. Here we filter down to just the ideas that are determined to be novel. Let's see, these ideas were returned as dictionaries with all sorts of information about the ideas, and idea novelty added a new key to the dictionary called novel, which is either true or false. So we're filtering here down just to the novel ideas. Next, if parallel is set to 0, then we would just go through this loop that for each idea called doIdea, processed in serial fashion, it gets to say completed this idea and that idea after each iteration. Some error handling here, just in case of failure. And finally, it confirms all ideas were evaluated. Parallel processing was requested. Then it will arrange the ideas for parallel processing. Here it drops all the ideas into a queue and assign each idea to a GPU in round-robin fashion. As for the multiprocessing process itself, the process that it runs is called worker here. We'll get back to that later. So it runs through and appends them to a list to deal with later. Now here, once that all of the processes have been assigned a GPU, it adds to the end of their queue the none entry. And this is used as a flag to indicate to the workers that it's time to exit. So as soon as they get through all of their processes and get to the none entry, then they know, okay, I'm done. Now this loop says to wait for all of the processes in that list of parallel processes to finish. Until all of the parallel work is done, we cannot proceed past line 392. And then we get to 394 and see that all parallel processes are completed. Generate ideas. This process devises ideas for research projects. For each idea, it makes a high-level plan to investigate it, including code design choices and preferred experimental outcomes. Generate ideas function basically uses the LLM to generate new ideas to be experimented on by the AI scientist. In lines 84 to 96, if the caller specifies, return ideas saved in a file. These are ideas that were generated previously. So it prints and returns the saved ideas and stops processing and handles errors if the file is missing or poorly formatted. 98 to 110, it loads the starter ideas, gets the template code, loads the prompt just to get into character as a PhD student. And there it saves the prompt. Next, for each idea requested, as indicated in maxnum generations, we print the idea number, then try the following from 116 to 135, prompts the LLM to generate the first version of the current idea. So we're on idea number X and just generating the first version now by sending the correct prompt to the LLM. And note that this prompt is calling the LLM and telling it to generate something impactful and creative. Next up is iteratively improving on the task. So this loop will iterate on the idea as many times as requested by the caller, or until the LLM itself concludes that it is done. Note that if I am done is included in the text, then it will break early. And this, again, is calling the LLM. It's just getting a response. It sends it the original idea plus an idea reflection prompt, which tells it that it should consider the quality, novelty, and feasibility of the current idea and try to refine and improve the idea, sticking to the original spirit. Unless there's a severe problem that it notes with the idea, and then it can restart with a brand new concept. And that's all the LLM needs to generate new ideas. Finally, after improving enough, it appends it to the brainstorm history. Here's some error handling. Then once it's done with that list, it builds a collection of ideas, all in the form of dictionaries. So this is a list of dictionaries containing all the details for each idea. Finally, save all ideas to a file and return the list of ideas. Check idea novelty consults the literature to decide whether the new idea that it has is really new or not. To start, it opens up the starter code to build and train a standard vanilla GPT model. Then here, it gets the task description. This is the file to work with. It trains models. Use experiment.py to start and edit it for your new idea. Then for each idea, first avoid restarting any work in progress. So if the key, novel, is in the idea already, then that means it's already been checked for whether it's novel and does not need to be checked again. If it gets past there, it'll say, I'm checking this idea for novelty. Prepare space for its work in progress. And then for each iteration requested by the caller, tells the LLM to make a decision or to query for more papers so that it can make a decision on the novelty of this idea. Here, if the LLM says decision made, then it will end right there. It'll either break with novel being true or novel being false. Otherwise, if it needs to consult the literature some more, then it'll take the query from the LLM. Because it hasn't made a decision, it will make a query and say, I need to consult these papers. Here it reads the query and uses a third-party API to search for the papers required by keyword. If those keywords don't turn up any papers, then it'll say no papers found. Here it's building a list of papers that would be relevant to the current idea and may overlap with it. And if there's a paper that overlaps very well with this new idea, then of course the result will be more likely to be not novel. If any errors come up with the LLM or with the third-party API, then this will handle it. At the end of processing the current idea, it'll save the result in the idea dictionary. Finally, it stores all ideas in the file ideas.json and returns. And again, all these ideas will have a novel key associated with them by the end of this process. This is the worker process, which takes the GPU that was passed in and begins feeding ideas from the queue. Once it gets that empty idea, as mentioned before, it will break, but otherwise it'll just keep on feeding ideas to the doIdea procedure.